Welcome back, everybody. This is Miss Grossi again. And I'm doing a second follow-up video to working with the Pythagorean or trigonometric identities. And today we're going to focus specifically on those pesky little critters, the Pythagoreans, right? Um, a lot of times, if you started the first video with me, a lot of times students they get easily intimidated, and rightfully so. This is complex stuff. This isn't math one. It's not math two. This is for real. um, and so just know that where these come from, ultimately at the root of everything is this unit circle. And in the unit circle, you could create a right triangle. And so when we think about Pythagorean identities, I want you to relate it back to that concept. Oh, there actually is a right triangle working in the behind the scenes realm of this. Um, a lot of times you're going to see more of the Pythagorean identities when you get into heavier calculus and heavier relationships with engineering. So you very well might not use this, when you get past a certain level of math, especially when you go to college or into a certain track. But I think the point is more importantly is short term. I want you to know and remember that no matter how difficult it might seem, you will be able to find success. You are going to be able to do well on these complex problems. It's just a matter of practicing and really getting over that mental barrier, right? You're going to do a great job. And again, the more practice you do, the better. So that logic flow is going to be, you're really going to work that part of your brain. So let's going to get started. So first thing I'm going to do is just remind yourself or remind me of my identities. So I have three, especially for Pythagorean. So Pythagorean is anything with a square. So remember, Pythagorean theorem is a squared plus b squared is c squared. So my first Pythagorean identity is sine squared dash cosine squared equals 1, right? That's my first identity. My next one is 1 plus um, cotangent squared theta equals cosecant squared theta. And my last one is tangent squared theta plus 1 equals, whoopsie-doo, I'm just writing there, not good, equals secant squared theta. So some of you may notice a little pattern that I did there, but if you're looking for more ways to work those out, you can always go back to the first video and see my little trick for how I work it out as well. So go back there. I won't bring you through that again. I know it was a lot. So those are my identities. Let me go and I'm gonna work out this problem here. Let me move this. Yeah, I know it says problem two, but I'm just gonna. That's fine. I know it's question one. So first thing I want to do, and we're gonna add in some more algebra skills with this too. So I mean, definitely be aware of that. Like this isn't just like working with it. So what I want you to see here is what I do, and this is something that I give advice to folks, is whenever I see a square, right, my brain, and I like to draw these little eyeballs. This is kind of like what my brain does, is it's like a light bulb going off my head, right, when I see a square. So this piece right here, 1 minus cosine squared theta, it's in parentheses, so it's a group together. So this is a type of Pythagorean identity, but what's happened is there's been some changes done to it. So cosine squared, right, see it here, only occurs once in our Pythagorean identities with this 1 plus cosine squared theta equals 1. So something has been changed or moved around, to make it look like 1 minus cosine squared. So let's figure out what would be equivalent to 1 minus cosine squared. So, oh God, my handwriting's so bad. So if I want this to say, so in the blue, right, that's the original identity. What I have boxed in yellow here is the manipulated or altered identity. I like to use the word manipulate because it shows that we're just moving stuff around. In the yellow, it says 1 minus cosine squared. So in the blue, if I want to make this say 1 minus cosine squared, I'm going to just subtract cosine squared theta. Right? I'm allowed to do whatever I want to do with these problems as long as I just follow the fundamental rules, which is whatever you do to one side, do the other. So now that I did that, right, this yellow box here matches what's over here, right, next to this, my original problem. So the equivalent, you know, identity, whatever, is sine squared theta. And so what I can do is actually now, instead of keeping this complex 1 minus cosine squared x, I can just write sine squared theta. Now you can write x if you want. Again, I love theta, so I write with theta. Right. I know there's a movie that references thetas as a sorority. I won't get into that, but that's how it is. So you might know what I'm talking about. So, I have sine squared theta times cosecant theta. If I do some of the problems that I looked at earlier that were really simple, cosecant can be rewritten as 1 over sine. Ooh, now we're getting somewhere. Some of you might have some light bulbs going off in your head. Sine squared is just sine squared over 1, right? It's itself. We can't rewrite sine. So now, sine squared, let's multiply, right? Times 1 is sine squared over sine. And if I have, sine squared over sine, I can cancel out a sign on the top and a sign on the bottom, which means that I'm gonna get sine theta. And that's my final answer. So all this complex stuff up here, right, just turned out to be this one little tiny identity at the bottom. That's kind of the beauty of this math, is that it looks like a puzzle. So to recap, a key point from this problem is that in the beginning, I noticed and recognized that this square had something to do with the original Pythagorean identities that was changed in some way. So I had to try to figure out how exactly it was changed. And again, this is from a lot of practice, right? A lot of time practicing. Just know that if you're not there all the way yet, you'll get there. And so we can work it out. So number 3, I guess on here it's labeled number 3. I take a look at this problem, right? Tan theta, tan x, right, times 1 minus cosecant squared x. Again, my eyeballs, my brain, these little googly eyes, like, oh my gosh, what's that? Like, that is a Pythagorean identity. And so let me see what the original one looks like. So I'm going to scroll back up here, right? And okay, I see cosecant squared. So 1 plus cotan squared equals cosecant squared. And the original one is 1 plus cotan squared equals cosecant. Right, so that's the original one, right? I'm doing this on some scrap paper somewhere, right? Maybe in my head. I don't know. It's up to you. So how do we want to make, this, right, look the same? What would we have to do? Well, first of all, I would have to say 1 minus cosecant squared theta. So I'm going to go ahead and I'm going to subtract 1 minus cosecant squared theta. So I do that, right? Get 1 minus cosecant squared theta plus cotan squared theta, because I haven't done anything with that cotan yet, right? I'm just going to let it sit there. And then I'm going to see, okay, well, I just want this 1 minus cosine squared theta to be by itself. So I'm actually going to move this cotan squared theta to the other side. All right. Right, so 0, that don't matter. 0 is just 0. Like, it's just chilling. So 1 minus cosecant squared theta equals negative cotan squared theta. So I now have a little matchy match. So 1 minus cosecant squared theta is negative cotan squared theta. So I'm actually going to use this negative cotan squared theta. Don't put your negative. So tangent x, and I'll use x for some of my folks who like using x. I want to make sure you feel equally as valued here. So negative cotan squared x, right? Now, some of my folks who have watched the videos, you remember that tangent and cotangent inverses, right? So that means that one tan can cancel out one cotan. So tan goes away, one of the cotangents goes away. I'm still left though with a negative cotangent x. And that is going to be my answer. So I hope this helped you just kind of get used to manipulating the identities and just kind of working them out. Again, you're gonna do so great as you keep working through this. But have that belief in yourself that you can do it. I know it's hard. I know it's not easy. And you can practice really any problem now with these two videos. And so, yes, it'll take a minute, but I'll see you again. And I hope that you just do your best and practice with each other. All right. Thank you all very much. I hope you have a great day.